Hello, how are you doing? So today we will learn something to do with this is our lesson 2. So let me open, please give me time to open lesson 2. This is our lesson 2. Yes, here it is. So our lesson 2 today talks about understanding variables and relationships. Understanding variables and relationships. So when we talk about variables and relationships, the topic is on regression and correlation. So we want to understand regression analysis. So what is a variable? In statistics, in statistics, a variable is simply any characteristics or quantity that can be measured. So anything that can be measured, counted, and whose value can change or vary. So that is what we call a variable. Variables can be two, x and y. There is the dependent variable and independent variable. When we talk about the independent variable, this is the variable that is thought to influence or cause a change in another variable. So it is an influencer predictor that is independent. For example, the number of hours you study influences the exam outcome. So what is the main point here? The number of hours you study. But let us twist this way. The exam cannot influence the number of hours you study. It's up to you. But the number of hours can influence the outcome to a certain extent. Years of experience can also influence the salary you will earn as an employee. Advertising can also influence how much sales you make in your business. So those are called independent, those that influence. Those are called independent. Dependent is those that depend. That is the word dependent. So the word is dependent. So those that depend. Number of hours. The exam result is dependent on number of hours you study. The exam score. The salary you earn is dependent on the number of years of experience. So those are dependent. Sales is dependent on how well you advertise. So those are called dependent variable. So this you may be a manager in a certain uh, entity or a company. So regression is very important. It is a subject you need to take an interest in. So why study this relationship? Understanding how variables relate to each other is crucial for decision making. For instance, does the amount of exercise a person gets influences their health outcome? Does it? And is health dependent or independent? So the exercise is independent while health is the dependent variable. I say myself, for example, maybe I'm slimmer. The number of times I eat or how much I eat sometimes is, yes, it's dependent on the how much I eat and or the food. But then that may not mean that definitely I will be or I will grow more fatter. So, but the independent here is eating, right? The number of times you eat, and the end goal is increase in weight. So, why then do we study? This can be used in future to predict sales, to predict marketing, how much you will spend, how much you will exercise. So all those, if you want to make sure as a manager, this is management accounting. So if you are interested as a manager to predict the future and the outcome, then you need to study these relationships. So here is a script from, or this I have gotten it from the course. So, and it gives 10 items or observation. The manager of a company with 10 operating plants of similar size producing small components have observed the following patterns of expenditure on inspection and defective parts. So what's the dependent and the independent? The dependent here, X here is X and here is Y. So the inspection is X, while defective parts is. So if we do this, we will draw a graph. We will draw a graph. So we will draw a scatter graph. Here is X and here is Y. So let us assume here is 10, 15, 20, and then here is say 10, 20, 30, 40. So 25 to 50. So if we take 25 to 50 and then draw it there, another one here, another one here, another. So we follow this 25, 50, and then we follow another one, and then we draw those points or sketch those points, and then tunaunganisha hivyo. We draw the line of best fit. So this scatter diagram will give us a clue. Why? As we move forward, that's what you'll see. So this is how this was sketched. This is how that was sketched. And if we proceed, we visualize. We say sometimes a picture is 1,000 equivalent to 1,000 words. So when you draw a graph like this, you will have a better understanding of that data. You will visualize. So the scatter plot, the first step is to understand the relationship, is to see it. By seeing it, you understand. A scatter plot is a graph where each point represents a pair of values for our two variables, x and y. The way these points are arranged on the graph reveals the nature of their relationships. The nature of their relationships. So, how then do we describe these relationships? We can describe in several ways. So, types of linear patterns. When looking at a scatter plot, we observe different patterns that tell us how x and y are related. These patterns describe the direction and strength of linear relationships. So today, someone wrote in the group that they have a date. So we want to learn if that is perfect relationship, perfect negative relationship, or what is it? So different types of relationships. So the first relationship is perfect positive relationships, which I will explain later. The second one is perfect negative relationships. The third one is high positive relationships. And then the fourth one is high negative relationships. And then lastly is no particular relationship. And each one we will give an example. Look at where the arrow is looking. It's starting from here. This is perfect. If you see something like this, we call it perfect. This is perfect positive relationship. This is also perfect but negative. This is also perfect but negative. Again, this is, you will see there are points which are outside, slight points. So this we call high positive. It's not full, but high positive. Again, this also high negative. This is where the arrows are heading. And then here, there's no particular relationship. There's no particular relationship. So what is positive, perfect positive relationship? Does it mean the relationship which we normally talk about, man and woman? We will see. All points fall exactly on a straight line that goes upwards, like this one. Here it is. This is a good example. So All points fall on a perfect straight line that looks at upwards. And then what does it increase? As x increases, y increases by a perfect consistent amount. There is an exact direct upward trend. There is an exact upward trend. Example. For example, we normally you may be trading USD to Kenyan shillings. So one USD is equal to 150. 2 USD is equal to 300. So if you draw a graph using these figures, if you draw a graph, here is, let us say, 1, 2, 3. Then here is Kenyan shillings. Here is 150. Here is 300. So what will happen? Here, here. So it will move that way. It will move that way. Sorry. It will move. Uh, it will move that way. It will move that way in a straight line. So this is perfect. This is an example of perfect positive relationships. The next one is perfect negative relationships. All points. So it is opposite of this. It's opposite of this. It's opposite of this. It's opposite of this. But what happens? It's opposite of this, but it starts from this side and goes that way. It's opposite of the first one we have done. So what's an example? What's a good example? So for example, you are in a matatu. If you go to in a matatu or a bus, as someone sits, the numbers reduces. As people enter the matatu, as one person enters, then it reduces until it goes down. So this is a downward from left to right, from left to right. So that is perfect negative relationships. High positive relationships points generally to upward from left to right, but this one has some inconsistencies. Example, example is example is often a person exercises, the higher the physical fitness. But sometimes not every person loses weight or develops that physical exercise. So it depends with the person. So then there might be a relationship, but there are some items or some people who fall inside and outside that perfect fit line. And then there is high negative. This opposite again of high positive, but it goes from up to down. So, for example, the market value of an equipment goes with age. The older the piece of equipment, the lesser the value or the lower the value. But sometimes, so age reduces the value. Sometimes that is not the case for some assets, for some vehicles. So what will happen? Some might again maintain their value. That slight variation causes negative relationship, but not as perfect as the first perfect negative relationships. An example like the bus. As people sit, the seats reduces. So that is perfect. But this one is not perfect because there are some variances. And the last one is no particular relationship. There is no discernible linear connection between X and Y. Knowing X doesn't help predict Y. Student height and the number of books someone reads, or the student age and IQ, or there's so many things which can't be related with. So there's no particular relationship. Yes. So a good example is student height and the number of books someone reads. There's no perfect relationship. So modeling, we will handle something to do with modeling. When we talk about modeling relationships, we use an example, simple linear regression. If you observe a clear linear pattern, like the positive or negative relationships above on a scatter plot, we can then use regression analysis to build a mathematical model of that relation. This model is usually a straight line that best fits the data. So what is regression analysis? Regression analysis is a powerful tool that helps us, one, quantify the nature of the relationship between a dependent variable of y and an independent variable of x. It also helps us predict a model, a line, that allows us to estimate the value of y for a given value of x. The line of best fit. The regression line. The goal of simple linear regression is to find the straight line that best represents the trend. In our scatter plot, the line is called regression line. So scatter plot, you remember? Yes, we will go to scatter plot. So it's a line of best fit. The line of best fit, the regression line. The goal of simple linear regression is to find the line that best represents the trend in a scatter plot. This line is called the regression line. It acts as a predictive model. So component of regression. So regression, there is an equation y is equal to a plus bx. So let us break down into parts in the context of the data. Y here, y is the dependent variable. X is the independent variable. This is the variable we are using to make the prediction advertising budget years of experience. A y-intercept, this is the estimated value of y and x is equal to 0. It is the point where a regression line crosses the y-axis. It often represents baseline or starting value of y. P-slope. This slope tells us how much y is expected to change for every 1 unit of increase in x. If positive, the line slopes upwards. So the line, if it's positive, the line slopes upwards. If it is negative, the line slopes downwards. Slopes upwards and downwards. The larger the numerical value of P, regardless of the sign, the steeper the slope. The steeper the slope. So the steeper the slope, or so depending on where your y-axis, x and y-axis are, the steeper the slope. So that is the case. So that is the case. So the larger the numerical of this p, regardless, the steeper the slope, indicating a stronger estimated impact of x and y. So finding the line, the least square method. So this is also tested. How do we then find the best line? The least square method is a mathematical technique that calculates the value of a and b, that creates the line which minimizes the sum of the square vertical distance between each actual data. And the regression line, simply put, it finds the line that is closest to all the data points. So what's the purpose of regression? I said if you're a manager, it will help you in future prediction and forecasting. Using the established relationship to estimate unknown values of y for new values of x. Understanding the relationship. Quantifying the estimated impact, slope P, of one variable on another. Decision making. Providing data driven insights to support business, strategic, and operational choices. So that is a short introduction for regression analysis. Now we move to solve one question. So I will help you solve this question and then I will leave the other one to you. Since we have solved, this is a summary of our class today. So calculate. The question here is calculate the product moment of correlation given the data below. So this question is just 5 marks. But the other question is 15 marks. Naturally, this question comes in 15 marks. So please learn and practice as much as you can. So I will give you the answer to both questions, but I will solve the first one. So I will solve the first one. So what you will do is first, you will create this table. You can see this table, right? So you will come up with this table. So if you look at this is our x. So this is our x 1, 2, 3, 4, 5. X 1, 2, 3, 4, 5. Those are how many numbers? 5 numbers. So look at this question. R. You are told R is equal to, first calculate the upside and downside. R, you are told, n, sum of xy minus sum of x, sum of y. This is times. Learn that. That is times. So what we are supposed to do is come up with this. Come up with this. What will you come up with? We will come up with, first come up with x, come up with y, come up with xy, come up with x squared and y squared. Once you do that, let us do, we have 1, 2, 3, 4, 5. You just sum. Sum of x is equal to 15, right? And then sum of y is equal to 25. Sum of xy is equal to 88. Sum of, how do we get xy? You multiply these two. Once you multiply, that's what you get. X times y is equal to 2. 1 times 2. 2 times 5 is equal to 10. 3 times 3 is equal to 9. 4 times 8 is equal to 2. 5 times 7 is equal to 35. So you calculate all this. So xy, we have 88. X squared, again, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. You get the summation. Once you get the summation, you do the same for y. So now let us work on our question. How do we solve this? So the first one is n sum of, here is sigma xy. How do we get that? Minus sum of x, sum of y. So here n, 1, 2, 3, 4, 5. Our n is 5. Sum of y. What do we mean sum of xy? What do we mean sum of xy? Here it is. Here it is. So 88. Here it is. Sum of xy. Umegonganisha x na y, sum yake ndio unachukua. That is 88. So we have that one. Minus sum of x, sum of y. So where is sum of x? Be careful. Here I will use brown color. So this is sum of x. This is sum of y. So you get sum of x, which is 15, times sum of y, which is 25. Sum of x, which is 15 times 25. So let us put this into bracket. And then we close this bracket. So let us calculate the top part. 5 times 88 minus 15 times 25. So that's how much? That is how much? 5 times 88. Let me use my calculator. 5 times 88. 5 times 88. 5 times 88. That is 440. That is 440 minus 15 times 25. 15 times 25. That is 375. So this is just the top part. So for 440 minus 375. 375. That is 65. So here at the top part, we have 65. Let us go to the bottom part. Let us go to the bottom part using this formula. So we are using this formula. So we start with the square root, but square root should be the last item you will handle. Square root should be the last item you will handle. What do we start with? We will start with n. N we know. So we say I will use color black. So n sum of x squared minus sum of x here squared. What does this mean? So what this means is, where is x squared? Where is x squared? X squared is here. X squared is here. X squared is here. So what do we do? 5 times 55 minus 15 square. So minus 15 square. And then unagonga hizi, unagonga na nini? I will use another color. Which color will I use? I will use blue. I will use blue. So here we are repeating what we have done with x but for y. So y squared is here. So 5 times 151 and then minus here sum of x squared, sum of y squared, 25 squared. So and then we do a square root for all this. So let us continue. Let us continue. So let us continue with our calculation. So 5 times 25. 5 times 55, sorry. That is 275. So 275 minus 15 squared. 15 times 15, 225. Unatawanisha hapo. And then here 5 times 151, that is 755. 755 minus 25 times 25, that is 625. So we are continuing. So 275 minus 225, that is 50. I'm rushing a little bit. Minus, yeah, sorry, times 755 minus 625, that is 130. This 130. So you multiply, that is 65 times 50, 6500. So this is what you will square root 6500. Square root of 6500. How much? You will get about 80. 80 times 80, that is 64. 80 point something. So here is 80. About 80 point something. So 65 divided by 80. That will give you 0.8. That will give you 0.8. Here, the closer you are to 1, the higher the correlation, the higher the relationship. So, there is high relationship between x and y. So, the other question, this was a short summary. The other question, I will leave it to you. Thank you and enjoy your night. I will give you the answer to this question, and already I have solved this. This is the table. So the answer is 0.99. So here there is strong relationship between fans, and customer favorite. Between fans and customer favorite. Thank you and enjoy your night. Thank you and enjoy your night. This is lesson 2. This is lesson 2, and we are handling uh, the paper. Thank you and enjoy your night. Thank you and enjoy your night. Okay, thank you very much. Thank you for your patience and thank you for listening.